Okay, so this is problem 2.8.49, and the question that was asked was just on part D of the problem, so that's the part I'm going to do. And they gave you in the problem f of x is 4x squared, and g of x is 9 times the square root of x, and they're asking us to find g circle g. So they want us to find the composition of g with itself, and then we're also going to find the domain of the resulting function when we get there. Okay, so remember that g circle g means that we're actually trying to identify g of x. So what we're doing here is we're actually taking g of x and we're inputting it into g of x. Okay, so I actually think when you're trying to do this, compose a function with itself, it's actually helpful to write it out twice, so you can actually visually see that I'm taking this and I'm plugging it in for the x, and then I'm going to simplify that. Okay, so g of x, when I plug this in for x, I end up with 9 times the square root of 9 times the square root of x. Whoops. Okay, and let me actually write that a little bigger. Okay, so when we plug this in, we're taking 9 root x and we're replacing the x with that. So this becomes 9 times the square root of x, and this 9 square root x is what we're replacing there. Okay, so then we need to simplify this. Well, taking the square root of 9 is not a big deal. The square root of 9 is 3. So let's just do that. So this square root of 9 here becomes 3. And then we're actually left with the square root of the square root of x, which we need to simplify. Well, let's first of all just take the 9 times the 3 here, and that'll give us 27. Okay. All right, now in order to deal with the square root of x, what we're going to do is we're actually going to convert these into fractional exponents. So if you remember, a radical, so if we have the square root of x, and there's an assumed 2 here and a power of 1 here, this converts in the fractional form to x to the 1/2 power. Okay, and that's just by definition. Radicals and fractional exponents just go back and forth in that way. So what we're going to do here is we're going to call this x to the 1/2, and that's also raised to another 1/2. This x to the 1/2 power right here is this inside radical in its fractional exponent form. But that is actually being taken to, also has the square root of that. So that's actually being taken again to a power of 1/2. So we're going to take, when we convert this, it becomes x to the 1/2, and that whole thing then taken to the 1/2 power. Okay, and then we need to simplify that. And when you have a power to a power, you multiply. So this would become 27 x to the 1/4 power. I would just multiply the 1s and the 2s. And then if we want to convert that back into a radical form, I'm going to kind of go sideways here. This becomes 27 times the 4th root of x. Okay, and again, that's just converting this. If we have 27 times x to the 1/4 power, if we go in the reverse direction and just convert this into a radical, it's going to have an index of 4 and a power of 1. So our g of x actually becomes, actually we need to do the domain as well, so let me just continue that on another piece of paper. Yeah, so our g of x here becomes this. Okay, so 27 times the 4th root of x. And then they want us to also find the domain. And when you're looking for domain, you have to look at two things. You have to look at the restriction on your input function, and then also any restrictions that occur on the resulting function. So our input function is, the 9 times the square root of x. And our resulting function is this here. These are actually going to have the same restriction. The restriction here on g of x is from 0 out to infinity. And that's because of the radical here. We need to have our radicand be positive. So you would say, well, I need to set x greater than or equal to 0. And what I'm doing right now is I'm finding domain. So I need to set the radicand, which is x, greater than or equal to 0, and then solve that. Well, there's nothing to do to solve there. It's just, if I were to list that in interval notation, it becomes from 0 out to infinity. So that would be the restriction on the input. The restriction on the output is actually the same restriction. And so the overall restriction, we don't have to combine anything here, but the overall restriction would be from 0 to infinity. So that would be our domain for our composition. And that's it in that problem.